We'll start shortly, 2:01. Hello, and welcome. Our next speaker is a core maintainer for the Open Hatch project, a tutor of Python, both professionally and otherwise. And she founded the University of Waterloo Women in Computer Science Undergraduate Committee. So please help me welcome Elana Hashman. Thank you.
Hi, everyone. I'm Elana. Some of you may know me as E. Hashman, and I'm really excited to be here to speak with you today about teaching Python, specifically the hard parts. So I'll give you a little bit of background on what motivated this talk and how it became to be. In spring of 2014, Mako Hill at the University of Washington put on a series of community data science workshops based off the Boston Python workshops curriculum. And these were aimed at individuals with no previous programming experience, many of them graduate students in the Department of Communication. The format of the workshops was as follows. There is a setup session on the first Friday night, and then 3 full-day Saturday workshops spaced 2 to 3 weeks apart, although I believe they are now closer. I helped out as a mentor at the inaugural first 2 sessions, and I thought they were super awesome, so I wanted to bring them to the University of Waterloo, my own UW. So in fall of 2014, the Python Software Foundation Educational Committee gave me a grant to run these workshops at the University of Waterloo for students with no previous programming experience. We worked with a group of mostly undergraduate students in programs with no required programming classes and no prior programming experience, including some graduate students and staff. And we held the workshops in the same format as the community data science workshops, with 1 setup night and 3 Saturday workshops. And yes, that is a photo of me doing a live coding demo. I was significantly more brave in front of an audience of 50 people. If you're at all interested, you can find a little bit more about these workshops on the U Waterloo Undergrad Women in Computer Science blog, and I'll have a link at the end of the talk. So we worked with the initial curriculum from the community data science workshops, which involved building enough skills in Python to fetch data and do some basic data science stuff. And things went really well, and we had excellent reviews from students, but that's not to say we didn't have a number of problems. So in both of these series of workshops, the organizers published a reflections document on lessons that we learned in the hopes that others would not make some of the same mistakes. So expounding on that and on my experience professionally mentoring and tutoring Python at various levels, I wanted to share with you some of the hard parts I've run into, both teaching and learning Python. So we'll start with some problems I encountered that primarily affect total beginners, that is, individuals with no previous programming experience. So in the context of these workshops, our instructional team consisted of a lecturer and a team of mentors or TAs. And the first thing we noticed at the community data science workshops was that most of the mentors ran OS X or Linux, but the vast majority of the students had Windows laptops. And when you're running a bring your own device workshop, you need to budget for some setup problems. So we had scheduled that full night for setup to try to predict and iron out any Python installation problems, so it wouldn't take away from class time and engagement. We still ran into a number of problems. So, and the mentors may not actually have the skills to be able to diagnose platform problems that they don't personally use. So some examples of this include python.exe not found if Python was not properly installed in the path at Windows install time, which is really easy to solve if you've seen it before and really difficult if you have no idea what's going on, as like finding the place to stick this configuration value is not super obvious. String encoding for Unicode on the Windows console. We worked with the Python Twitter API, and one of our examples, which was sort of the hello world example, printed a real-time feed of tweets from Twitter throughout the world, and the Windows console could not display it because of character encoding issues, and it would throw an exception, and everything was very sad. And last, Python tries to helpfully and quietly convert line endings automatically for Windows users, which can cause unexpected problems, particularly when you're working with binary files. So here's an example of some code that we wrote at the UWaterloo Python workshops for beginners. The students are learning how to work with the web APIs, and they're super excited about using Python to do this programmatic stuff. So here we are downloading this adorable placeholder image from the PlaceKitten API, and we open the URL, we read the data, we open a file to write that to, we write the data to the file, we close it, and then the students open up the file to see the fruits of their labors. And guess what happens? So someone is like, my kitten is a demon. And I'm like, what? What do you mean it's a demon? And actually the kitten that they had was indeed this demon kitten on the left. And nobody had a clue as to what was going on there. None of us had used Python on Windows or had this problem before. And it turns out that if you run this code on Windows, Python helpfully tries to convert all the line endings from DOS to Unix, which corrupts the JPEG. So we realized after a bit of poking around, we needed to specify the binary flag, like on the right. And then this worked totally fine, but it stumped our mentors for a bit because only one person had worked with Python on Windows previously. We had never seen anything like that. So what can we take away from this? First, you must anticipate that you will have cross-platform issues for your participants if you let them all bring their own devices. Make sure you test your examples and curriculum on Windows if you're supporting it, in addition to any other platform you intend to support. That way your students won't encounter any unexpected surprises. So one of the first ways we introduce students to Python is we have them fire up the Python interpreter in a terminal. And sometimes we forget as instructors that most total beginners have never used the command line before. It's not something they would have ever encountered. Now, we were aware of this, and we did spend some time introducing the operating system shell before talking about this Python interpreter, but we still found that students got confused, and we probably should have spent more time working on this. So beginners tend to get confused between the two shells, and they'll type OS commands into the Python shell, or they'll type Python commands into the OS shell, and a common example of this is a student says across the room, LS isn't defined anymore, I don't know what's going on. And yeah, that's because you typed it into the Python shell, and that's a problem. And of course, depending on what version of Windows your students were using, and we did have at least one on XP during the workshops in 2014, they will not be able to use LS, they'll have to use dir. So you need to include that in your OS shell curriculum as well, and be aware of that platform diversity there. So what are our takeaways here? If your students' first exposure to Python consists of interactive exercises with the Python interpreter, take some time to first get them comfortable with the operating system shell. Teach students specific commands for each shell and how to tell them apart. So is like this the shell with the 3 arrows, or is this the one that ends in a $ or an angle bracket on Windows? And version politics notwithstanding, the question of Python 2 versus Python 3 is an important one for your students. So hopefully your students will ask you, which version do I install? But more likely what will happen is that one person will ask, and the rest of the class doesn't want to ask, so they'll just guess. And so you get half of the class that installs Python 2 and half of the class that installs Python 3. And I don't really have a suggestion which version of Python you should teach your workshops in. That's totally up to you. However, there are some things to be aware of as an instructor depending on which version you pick. For instance, the Python 3 libraries are incompatible with Python 2 in some cases and have different documentation. Furthermore, the search engine indexing is not that great for the Python 3 docs, so you will often search for Python whatever doc, and you'll get the Python 2 doc, and it'll be confusing because it'll say the wrong thing, and the beginners don't know that until it doesn't work, and then that's frustrating, and you get to figure that out together. So here's my takeaway from that. Trying to make everything Python 2.3 compatible is probably going to be a waste of your time. You should spend your time teaching. It takes time away from building your curriculum and may end up confusing beginners, so just stay away from that. Pick a version of Python that works for you and your group. Proceed with that. And make sure you are aware of Python versioning at setup and install time. And definitely ensure that your class is using the same version of Python and that it's the one that you've written all of your examples for, or you might have a bad time. So those were some of the most common examples we encountered with students who had never programmed before issues that they had encountered. So let's talk about students who are a little bit more advanced now. Maybe this is the second or third workshop in a series, or you're teaching people Python that have some prior programming experience. And so these are students that are a little bit more advanced than our Python workshops for beginners or community data science workshops crowd. When I say student, this isn't limited to the context of workshop or classroom participants. Much of this can also be applied to tutoring or a professional mentoring context. We are all ongoing students of Python as far as I'm concerned. So, a common question that I've encountered is, why do we write foo.keys, but range of 10? Why not keys of foo? And you may be tempted to answer, well, one is a function and one is a method. But for a student that doesn't have any previous object-oriented programming experience, this sounds arcane, isn't relevant, and doesn't really answer their question, because certainly in other languages, keys of foo is totally fine. And another question you might hear is, well, when do I use foo.sort, and when do I use sorted of foo? And then you really might be tempted to answer, well, one mutates foo and the other doesn't. That's important, but what is mutation? What's a function? What's a method? Trying to explain this all to relatively junior students is overwhelming and confusing. They don't have the tools to understand this yet. They've only been programming for a few days or weeks, and most CS programs at the university level give their students a year before they introduce object-oriented programming. So they just don't have the tools to understand this yet. So what can we do about this? I would prepare for these questions because I suspect it will be something that you encounter, and the different syntax with seemingly random usage can be confusing to students. Mentors should be aware of this and ready to help out. You don't need to teach your students object-oriented programming to help them with finding the right syntax in different contexts. One really great thing about this is a student may ask you, okay, well, is it foo.len or is it len of foo? And you blank out for a moment because you haven't written Python in a few months, and then you say, I don't know, let's go look that up together. And this helps to reinforce that even experienced Python programmers can get confused or don't know everything, and it gives your students permission to feel the same way. So as your students get a little more mature, you want to start teaching them the skills to ask questions and fend for themselves. And this is a great opportunity for that. Looking up documentation is great here. And finally, I would strongly advise you to avoid introducing OOP to beginners or near beginners if at all possible. If you have to talk about it, put it at the end of your curriculum. Programming is not software engineering, and this kind of design takes experience to motivate. In fact, I would go so far as to say that I give you permission to teach your students OOP, but only after you have covered a unit on testing. So, testing can be a blind spot for some people. My university's computer science classes didn't start requiring tests until my second year, and then after that class they became optional again. And the later you introduce testing to your students, the more optional it seems, and the harder it is to get into the mindset of doing it as a regular activity. There's a temptation to try to cover as many cool language features as possible. You want to focus on the shiny and the awesome in these beginner workshops. And testing feels a little bit like eating your vegetables, so it's maybe harder to motivate. And I'm guilty of this. I didn't even think of talking about testing in the Python workshops for beginners. So I might justify that to myself saying, well, these are like complete beginners. Is this really something they need to learn right now? Is that like a distraction? And so there's a question, is there a place for something like this in a curriculum for total beginners? And I would say, I think the answer is yes. Unit test is easy to get set up and running, and it's certainly no harder than ERLib2 or third-party libraries and APIs. I do think that there is a place for this in curriculum, even for the most inexperienced students. Many of the students ask, well, how do I know this is right? Or they express worry that when they write code, they're just kind of throwing stuff at the wall until it sticks, and testing can help them build a more disciplined mindset towards writing code and build their confidence in what they're writing. So my takeaway from this is that I think you should consider including some curriculum on testing if you're planning on teaching Python, even if it's for complete beginners. And even if you decide you don't want to cover this as a unit, you still have the opportunity to gently introduce testing. For instance, you could include tests in your examples when you're lecturing or in your sample code that you distribute to your students. Okay, so you're proceeding through your curriculum. Everything looks great so far. Your students are building these awesome little programs, and they're at the point where they have enough foundational skills to put some really cool things together. So what happens when they try a more ambitious project? What happens when the code gets too big to fit in one file? And where do you put all these tests that I just told you to write, right? So you have some options here. You could maybe ask a mentor. This is something that I often do. You could also despair. And I'm not joking about this because as a professional Python programmer, this is something that I've struggled with. The documentation is poor and everything seems to be different between versions. And it's not just like different between versions on one thing. There are various axes that are problematic. If you're dealing with absolute versus relative imports, if you're dealing with namespaces versus packaging, which the packages are the same as namespaces except when they're not, and everything is terrible. And as a bonus, as soon as you choose to split your code out into modules, you get the added joy of dealing with setup tools. We're obviously all very joyous about that. So what can we do about this? First, we breathe. And then we pick a strategy that works for the version of Python we're using and our group. And we can offer our students a templated solution which solves all these problems. So here's an example I put together for my highly important cat analyzer project that I can feed images from PlaceKitten into. And so we've got like a base directory and a dunderin.py file and our tests and the readme and a templated setup.py, and we include code with absolute imports, as you can see on the right. And this may also be a place for an opportunity in your curriculum to talk about circular imports and how to avoid that problem, since students are unlikely to be aware that that's even going to be a problem if this is their first time programming, and they may accidentally get themselves in trouble when they try to split things up. So in conclusion, if you're teaching non-beginners, or even if you're teaching beginners and you're working on a long series of workshops, please cover this, because it preempts what may be a large source of stress for your learners. We can ease this documentation gap by using our expertise. And I think maybe part of why this is a common curriculum gap is because as instructors, it just seems so obvious how to structure our code. But for what it's worth, this can be a point of frustration for new Python programmers coming from many years of experience in other languages. It has definitely been a pain point for me personally. And hence, I'd like to encourage you strongly to cover this at this level. If you don't cover it, make sure you can provide your students with resources that they can access in the future to help them with these things. So, on to intermediate students. In this category, I'd like to talk about learners that come to Python with previous programming experience, who know how to write software, but they just haven't learned Python yet. So intermediate students often ask questions about Python scoping to learn how to reason about their code. Is it lexical? Is there some dynamic scoping? Something else going on? And Python is a little special because of the way we declare variables, so things don't necessarily work out the way people might expect from other languages, and this can be very frustrating. So while confusion over Python scoping could be a talk in itself, I'm going to stick with just one common confusing example, and we'll chat a little bit about that. So here I have some cat swapping code. So at the top level, I have a cat which I've set to meow, and then I define this cat changer which sets cat to purr, and I run this code, and what happens? Oh no, it didn't work. Why didn't it work? Well, it turns out that variables in Python are local to the scope in which we assign to them. So the cat we assigned to was a local cat inside of cat changer and not the cat at the outer scope. And there are a bunch of different ways we can address this scenario. We can teach students to pass in a reference so we can properly mutate the value. We could approach the problem in a way that doesn't require mutation. That's like a shout out to my Clojure friends there. We can even refer to cat as a global variable. Various solutions are going to be better suited for students of different levels, so guide them appropriately. And another scoping problem that relates back to building modules. Now that I've split up my code into all these different files, how do I share variables or state between the two? So you should do this very carefully. On some of the other talks I imagine you've seen thus far, you might have seen some of the problems that come from, for instance, not using fully qualified namespaces. So please, please, please teach your students to do this, and it will save everyone headaches. Another common problem in this space is how we might pass around global config variables, and using a single config.py module is a great idea and considered Pythonic. And this is actually a really gentle and easy example for beginners. So here's how I might include a config.py in my cat analyzer. So what can we take away from this? First, Python scoping rules can be tricky, even for experienced programmers using the language for the first time. And trust me, I wanted to put like 5,000 examples in here, but then I restrained myself and decided not to. What you teach your students here will be very dependent on their level. In a classroom context, you can try to cover some worst case sort of heads up scenarios where students will run into trouble, and if you can, talk about scoping rules in detail. And if you can, show your students how to share global variables and state between files in a Pythonic way, because this helps a lot with putting things into modules. So, packaging and deployment. Students want to ship their code. And a lot of students will come into your workshop motivated to do a specific thing. Beginners especially want to write a cool dynamic website or a mobile app. And a key thing to be aware of is that they're not doing it specifically because they want to come learn Python. They're at your Python workshop because they want to learn how to do a cool thing. So they ask me, how do I write a web app? How do I write a mobile app? How do I package and deploy a command line Python application? How do I write a Python service? And I promised you in my abstract I'd cover this section, and I didn't want to completely disappoint you, but I'm going to maybe follow my advice here and maybe abandon hope. And if you were at either maybe Glyph or Paul's talks earlier, you might have some idea as to why. Python packaging and deployment is difficult even for language experts, and this section probably deserves a dozen talks all on its own. So you can go and look up some of them on YouTube. So I'm going to skip over these slides, but I'm going to include them in what I'm uploading to SpeakerDeck and my website, and I'm just not going to talk about this right now because it's a mess and will make all of us very sad. So you're like, look at this. This is terrible. DH virtual and the Debian package is sweet. Last, I'd like to close with some advice for students of all levels. General advice that I think really helped bring our workshop experience to the next level for our students, and also explicitly speak to some overall high-level advice I kind of hinted at throughout the talk. So, first, be aware of your own shortcomings as an instructor. Know your knowledge gaps. This doesn't make you a worse instructor. It makes you more focused and able to address unknowns. If your students need you to know Python on Windows, then you can go and learn Python on Windows. This doesn't have to be a knowledge gap for you. Less is more. Resist the temptation to offer your students a sampling of the whole language in order to try to demonstrate all these cool features that they might use later. Instead, focus on building foundational skills. They will be more confident and feel more secure if they grasp the material well, and this will encourage them to pursue their studies because they won't feel that they're proceeding with a weak foundation. Next, make sure to bring together a supportive educational team, and don't underestimate how much this improves both your own experience as an organizer and your students' experience. We consistently got feedback that the mentors at our workshops really improve the student experience, since I couldn't give all 50 students sufficient one-on-one time. Thus, we aimed for about a 1-to-5 mentor-to-student ratio, and this ensured that all of the students were able to receive sufficient personalized attention. Next, make sure you seek feedback from your mentors and from your students, and iterate on that feedback. We definitely did a lot better by workshop 3 in comparison to our first workshop. Students noticed and they appreciated that we incorporated their feedback. It made them feel heard and valued, and it gave things a more collaborative feel. As for your mentors, you couldn't do it without them. When you value their input and criticism, it strengthens your instructional team and brings you all closer together. So we actually held a closing mentor dinner after every session to talk about the good and the bad, and they were an awesome experience for everyone involved, and they helped us from an instructor level also improve a lot of the student experience. Next, make sure you treat your students with patience, empathy, and respect. And the same goes for your mentors. Sometimes we take our knowledge for granted and forget the things that come effortlessly to us now used to be really, really hard. So you should make sure that you set reasonable expectations, maybe even lower than you might have expected to begin with, and get excited about your students' small victories. Let them know that it's okay to be confused, and reinforce that with your own fallibility. Create a culture in which it's safe and okay to not know everything. Give your students brain breaks. This gives them time to work on examples, reinforce their learning, and socialize and make friends. And make sure you take care of your students. One of the top pieces of feedback we got from the students was that they were really appreciated how healthy and tasty our lunches were over the usual university free pizza, and how considerate it was that we accommodated all their dietary restrictions. Like at an 8-hour workshop, this really makes a big difference. When you go out of your way to care for your students' well-being, it makes them feel positive and valued, and ultimately helps them learn and motivates them to learn even more. Last, I would encourage you to encourage your students to build community. One of the most awesome parts of our workshops was that we brought together students from a lot of very diverse backgrounds. At the University of Waterloo, we're somewhat known for our isolation between the various faculties. So students in arts don't talk to students in science who don't talk to students in engineering. And it was a really great experience for the students to be able to make friends that they would have never run into otherwise because of this sort of faculty siloing. You have an opportunity to help foster these connections. So supply your students with the tools to do so. Give them mailing lists, you can help them connect via social media, set up outside meetups, organize sessions for them to work on their homework together, etc. So, any questions?
Do we have time? We have time for a few questions. Please direct your questions to the speaker and hold the more open-ended topics for after the talk. Thank you.
So if I'm going to teach, basic sort of procedural programming as the foundation, I've always got this sort of choice between imperative statements and data structures. Mm-hmm. So what should I start with, the imperative statements or the data structures, and how do I organize that?
That's a good question. I'm not sure that I can give you the all-encompassing one correct true answer. We certainly started with working with some statements, showing students how to add up numbers, and then sort of slowly ease them into working with maps. And we found that actually maps were pretty confusing for them, whereas doing math in Python was not. So that worked out for us in our group, but it may be really cool to focus on a more data structure driven thing. I guess it really depends on what your students' backgrounds are, what you feel comfortable teaching, that kind of thing.
Hi, thanks for doing this talk. It's really helpful. I just finished my first semester teaching Python to undergrad non-CS majors, and I noticed that you didn't really touch on code style, and I was wondering, what are your thoughts on teaching something like PEP 8 along with the curriculum, or how much to emphasize that for people who have no experience and it's just it's a victory just to run a program, let alone style it? Mm-hmm.
So one of the reasons that I did not touch on style or PEP 8 was that we did not run into a huge amount of difficulty with that. So I talked a little bit about best practices in terms of code structuring overall, not so much with linting and that kind of thing. The size of the projects that our students were working on were relatively small, under 100 lines. And as long as it ran, we were super happy. We didn't want to sort of distract them with other details. So certainly in the context of a semester-long course, that might make sense.
Hi, thanks for the talk. At what point would you recommend introducing source control as a concept?
That's a great question. So one of the reasons that we didn't touch source control is that we were working with total beginners. We were working on very relatively small things. If, for instance, they came into some mistake and they needed to blow away all of their work and start again from the beginning sample code, that was totally fine. I would recommend probably teaching students Git, because Git seems to be the sort of most popular source control right now, but Git is actually really confusing to teach beginners in my experience, and we did not want to take away from the programming content by adding in source control content. So if we were doing something which had more workshops, we really did not have that much time. 3 workshops is not a lot to teach total beginners. They're going from 0 to something. So if it was a longer scope thing, or if we did that in a separate workshop, and the Woman in Computer Science has run a number of Git workshops as well, but not in the context of both together. Maybe if the scope was a little bit wider.
Thanks for your excellent talk. I got the point about save OOP for late but get testing in early. And unit testing, you said, is easy to set up. But the question there is, isn't unit test is all about subclassing, test case, and then you write methods, and there's self all over the place. So in setting up unit test, aren't you putting OOP right in their face at that point? And what do you do about that?
So I guess the issue is that Python is one of those languages where you can't really hide OOP from your beginners at any stage in the process. Like when we do foo.keys, that's OOP right there. Now, in terms of these sorts of examples, like working with unit tests and whatnot, I mean, for the most part, when you're working with these beginners and you're providing them with code samples that they can play around with and modify, you're really just giving them templates. And you know, if you have like a sort of keener student who asks and really wants to know more, you might want to sit them down with a mentor. But I would try to deflect those concepts until you start having them organize code into larger modules and things like that. I'm not saying that, like, I certainly, there is a sort of chicken and the egg problem there, but it's difficult to be able to motivate OOP if students don't know how to program, and this is one of my pet peeves with Python as an instructional language, is you can't hide that.
Thank you.
What about actually getting the students to code and coding together? Like in my experience, I can show them assignment statements and say, now let's go make this function that will make an area of a rectangle, and they seem to have gotten the concepts when we talk about it, but then they stare at you like they don't know what to do once you say, now do it yourself.
So to be clear, is the question about the students like independently programming outside of the context of the workshop, or is it about them working together on things?
Working together on things in the workshop.
Okay, great. So luckily for us, that wasn't actually much of a problem. And I think part of that was that one of the things that we told our mentors to do is if a student came to them and asked them a question, we'd say, we'd maybe look around, and often there were a lot of students with the same question, and we'd put them together and we'd make them try to work through it together first before the mentor came in and kind of, you know, Deus Ex'd their example. So that tended to work really well, and students just sort of organically worked together on a lot of these things. I think because they felt comfortable doing so, because they're like, well, none of us kind of know how to do any of this stuff. We're not from backgrounds that we would expect to be doing programming, so it's cool. We should work together as a team, combined intellect. So luckily that wasn't a problem for me. But you can definitely do stuff to foster those collaborative interactions in your classroom.
So one of the hardest things for me to explain to students is scoping, especially when you have global variables and local variables with the same name. Are there any metaphors that you use to explain what a scope is to students, and also to help explain all the different rules that come into play when you have a global variable and a local variable with the same name?
That's a really great question, and I feel like I'm really poorly equipped to answer that because I'm a math student and this is just never something I've thought about. So why don't I give you a rain check on that one? I'll try to think of a metaphor. Maybe I'll tweet it or something.
Yeah, it's tough for me too.
And I'm just going to switch over to my thank you slide so you don't just get to see the cute kitten.
I was really curious. You mentioned a couple times now, both in questions and else, that you don't want to explain object-oriented programming right away to beginning students. And I mean, I had struggled. For my first time teaching Python to kids, it was third graders, so it was a big challenge for me. But do you have any suggestions or strategies that how can you deflect those questions but still give them some useful information so that they, like, there is a difference, but like.
Yeah, so I mean, these are really hard questions, and like, I don't know, as a professional programmer myself, obviously I've developed these excellent skills at deflecting when people ask me really hard things. So I mean, you don't want to deflect too much because students may ask you more pointed questions, but you can deflect while giving them an answer to their question. So for instance, in the case of why do we use foo.keys and not keys of foo, the answer is, well, that's the way it happens to work in Python because it's not canonically true that it is wrong to use keys of foo to get the keys out of a dictionary. And in doing that, you don't have to talk about, well, it turns out that, foo is a dictionary and a dictionary is an object and there's iterables and blah, blah, blah. And yeah, you don't have to worry about any of that stuff.
Okay, Thank you.
So, thank you, really great job. We enjoyed. I have a question. You mentioned specifically things like unit testing and difficulties sometimes to get intro students to that kind of reasoning and stuff. Could you share some thoughts about dog testing that you might have experienced?
Sorry, could you repeat the question? I couldn't
Dog
hear.
testing? What are your thoughts about dog testing?
Not something that I've looked into, sorry.
Sure.
Hi, thank you for your talk. So I do a little bit of instruction of non-programmers and non-technicals at my job, and have very constrained time to do it in. So I just wanted to pick your brain on, if you had only 90 minutes or less to do a lesson, what would you do?
Oh, that's not a fair question. If I only had 90 minutes or less, I don't know. I wouldn't talk about programming. I'm a math major. You're going to motivate it, right?
I just wanted to say thank you for pointing out the whole thing about even the experts have questions, because that's a big barrier, I think, to a lot of people to think, well, I have stupid questions, but if you see people asking each other who are supposedly teaching, then you realize that it's okay to ask the stupid questions. So I just wanted to say thank you for doing that. We need more of that.
Thank you. I think this is going to be our last question.
Hi, so I have a question regarding kind of the pain points of the whole setup process. Have you explored doing like downloading VirtualBox, giving them an image and doing it that kind of setup? Have you ventured that way? And
So the way that we dealt with this on Windows user, or for Windows users, so the community data science workshops did involve like some NumPy examples, and so like all of this, trying to get this set up on Windows is a mess. So what we did on Mako's advice was we got all of the students to install Anaconda on Windows and also on OS X, because that was just easiest. And on Linux, we kind of knew how to deal with the problem, so we weren't super worried about anticipating them. So this actually worked out super well. Now, we didn't have them dropping into an IDE or anything for that sort of thing, but that also comes with all that stuff. And it does come with like it's mostly like, especially on a Windows environment, it's mostly clean. So you don't have to worry about the VirtualBox thing. Now that is like a 300 meg binary to install. So we actually had problems with wireless in the very tiny room that we were teaching in. And so we passed it around on USB sticks. So that's a possible solution to this sort of thing. I have not looked in like, you know, there's been no Vagrant stuff that I've looked into or anything like that. Like that's maybe too complicated.
okay, cool, thanks.
Awesome. So thank you everyone for coming to my talk. Thank you to all of these awesome people that helped me with various stages of my talk. Thank you to Rackspace for sending me here. Thanks to the closed captioners who I'm sure did an amazing job. And all of the conference staff who've helped make this talk possible. If you want to find some links or resources or the slides, I threw them up on my website. Thank you, captioners.